Bonjour and good afternoon. Welcome to WASA Distance Education Center and PLAR Science. So we're on to week 2, and this is our third class for the term so far. Again, just to mention to the students, on Thursday, that was on the 19th, we did have a power outage. So hopefully everyone received the message that we didn't have the radio broadcast, but we did have, it was available through Zoom. So hopefully students got the message for PLAR Science that we did do that through Zoom on Thursday, April 18th. So we are going to continue today. We're still working on lesson 1. A couple of announcements for term 2B. We are still continuing with having term 2B draws. We had the term 2A. We had 2 students, one from Mishke-Gugamang and one from Frenchman's Head. Those were the 2 winners that we had for term 2A. It will work the same way. We will have the 2 student draws, and it's one for students who earned a credit and one for students who submit work. Okay, I'm not quite sure what the prizes are yet, but we will let you know once we know. So make sure you submit your work to your teacher to be entered into the draw. And students, same as last term, students working on more than one course will have their names entered for each subject that they submit work for. So if you do the PLAR Science and you do all the lessons, you will get 5 entries, and then once you do the culminating, then you get another one for the 6th entry. Students can still register for independent learning or IL courses. You have to complete the course on or before June 13th. Same for the radio students. IL students can expect regular contacts by phone, email, or if you have Facebook, from your teacher. So speaking of contacts, you can still contact me through the office using the 1-800-667-3703. My extension number is 2204. You can fax your work if you want to. That's the 1-800-463-7852. My email, my Facebook, as I mentioned, it's same for my email. It's jmercer@nnec.on.ca. So the Facebook and YouTube profile starts with J Mercer, and then it says WASA at the end. My office hours, you can get that schedule from your DEC, and you can also call me at home. Several ways for you to submit your key question. As I've said, you can fax your work, or you can have your DEC fax your work for you. When you scan your work, you can email it to studentwork@nnec.on.ca. Make sure you CC it to the teacher that's marking your work, so we know that you have submitted key questions. You can use your Notes app using your phone. You can also send a picture through Messenger. This seems to be the popular way for students to send it if you're not emailing it. Or you can also drop it off at our WASA office. There is an outdoor mailbox on the side entrance. It says WASA mailbox on it. Make sure you put your name on your work before you put it in the slot there. Or you can just knock on the door and we could get your assignments from you. Again, make sure you put your name on your work. You can also submit your work as you complete them. So if you're doing the PLAR Science, you don't have to do all 5 lessons before submitting your work. You can submit work as you're completing them. Let's say if you have 10 key questions completed, you can submit them. And of course, you should contact your teacher if you need help. Okay, other support for you to do the PLAR Science and the PLAR History Geography. Same with the PLAR Math and PLAR English. We have on YouTube, we have playlist that's available for you. So if you look on J. Mercer Wassa on YouTube, you will notice that there's a PLAR Science 2B 2024. And there's 2 videos in there already. So that's the 2 classes that we've had so far. So that's the newest playlist. So as I do the class, I will be putting those classes on that or in that playlist. If you're working ahead for PLAR Science, you can go ahead and go to the PLAR Science 1B 2023-24. If you're working on lesson 2 already, then that's where you should go, because we haven't done the PLAR Science lesson 2 yet. If you're working on your PLAR Geography, there's the PLAR Geography playlist for 2A. And if you're working on the PLAR History, there's the PLAR History 2A. So notice it'll tell you how many classes are in that playlist. If you don't have access to internet or Wi-Fi, you can request a USB of classes. What we'll do is we'll download the classes for you on a flash drive. You will need a USB port, and you can view them either on your laptop, or if you want to on your television, or you can use your Xbox or your PlayStation. So you just need a USB port to insert the flash drive. When you're looking for a class, so if you have a PLAR Science flash drive or USB, you will notice it will give you the name of the course, in this case PLAR Science, then it will follow with the lesson, then the key questions. So for example, if you're having problems with key question 22, you will look for key questions. This one says lesson 1, key questions 21 to 26. So key question 22 will be in that video. So then you can choose that class and watch for the key question. Okay, so we're in week 2, as I've said, and we're still working on lesson 1, astronomy, and we should be able to finish that this week. A reminder to students, there are still a number of students who are holding on to their culminating activity, meaning that I have sent the culminating activity to you, but you have not completed and returned it to me. So remember, you have to return it in order for you to have your equivalent credits granted. In order for you to have your equivalent credit granted for PLAR Science, you need to get 50% and 50% or over, okay, to pass the PLAR Science. It's an open book test, so you can use your marked work and you can use your lessons when you're doing your culminating. Students that have previous versions of lesson 1, so let's say you have lesson 1 but it doesn't say 2023-24 on it, it might say 2022 to 2023, that's fine, but you just have to let me know so that I know that I'm marking a previous version of this lesson. So that means you don't have to redo it or start over. Okay, so far we have completed as far as we did up to key question 12. Let me just double check there. Yes, that's how far we have completed up to key question 12 from our last class. So we're almost halfway completing key questions, the key questions for lesson 1. Okay, let's see what our topics will be for this afternoon. So the last page that we worked on was about the sun and structure of the sun. So that was on page 19. This afternoon we will continue with page 21, planets in the solar system. Then we will look at planets, quick facts about each of the planets. Pages 23 to 26, what are the inner planets? And then pages 27 to 30, what are the outer planets? And then page 31, Earth's orbit. And page 32, the moon, which is the Earth satellite. So we might get as far as that or more. So we still have a few more topics that we need to do, and we'll probably have them done by Wednesday. Learning goals. I will understand the challenges and benefits of human space exploration. So keep that in mind as you're doing this lesson. Okay, planets in the solar system. So a planet is an object that's orbiting a star that is large enough to generate its own gravity. So we said there are 8 planets in the solar system. Some of them we can see without using a special telescope. So when you see that it can be seen with a naked eye, that's what it means. It means you can see it without using a telescope. In 2006, the International Astronomical Union, also known as IAU, they officially adopted a resolution defining planets within the solar system. Okay, so they based certain characteristics so that they can decide whether this is a planet or this is not a planet. This resolution caused some controversy because it means that some objects that used to be considered planets, for example, Pluto, are no longer defined as planets. If you remember when you were back in elementary school, there were 9 planets because Pluto was considered a planet. In 1930, Pluto became the 9th planet, and then from 1979 to 1999, it was the 8th planet in our solar system. And then they changed their mind. From 2000 to 2006, it was the 9th planet again. And then 2007 to 2014, just to change things up again, it was considered a dwarf planet. And a dwarf planet just means that it's an object in space that is like a small planet, but does not completely fit the technical description of a planet. Okay, so that's why there was a controversy about it. So more than 2,000 planets around other stars, also known as exoplanets, have been discovered in the Milky Way. So they range in size from just above the size of the moon to gas giants about twice as large as Jupiter. So all planets in our solar system have their own orbits around the sun, meaning they all have their own path. So the closer the planet is to the sun, the shorter the distance or time it takes to complete these orbits or revolutions. So at the same time the planets are rotating on their axis, a rotation is one spin on its axis, while a revolution or orbit is a movement of one object around another. So if you think about rotation versus revolution, if you took a ball or a basketball and you try to spin it on your finger, okay, that's a rotation. Or if you've seen a ballerina dancing, okay, they're on their tippy toes, and if they rotate or spin, okay, that's another example of rotation. Whereas a revolution, so if you're picture yourself if you had a chair and you kept going around the chair, so that's a revolution. Okay, you're not fixed in one place. The chair is, but you're going around it. So why are those two important? The words revolution and rotation. Well, Earth's rotation, so the spinning, creates day and night. Okay, so as the Earth is rotating, that means parts of it is facing the sun. And as it's rotating, sometimes it faces the sun. So it goes on a 24-hour spin. Earth's revolution creates seasons. And you probably guessed how many days it takes for the Earth to do its complete revolution. 365.25 days, which basically is a year. Also, rotations give planets sunrise and sunset, and then the revolutions give the seasons for each of the planets. So how do you remember the order of the planets? So you could try and create a sentence, or what is called a mnemonic, meaning a clue. So you could take each letter that the planet starts with. So M for Mercury, V for Venus, E for Earth, M for Mars, okay, J for Jupiter, S for Saturn, U for Uranus, and N for Neptune. You can say, my very educated mother just served us noodles or nachos. One student wrote, Mom visits every Monday, just stays until noon. Okay, and that was many years ago that a student had mentioned that, but I can still remember it. So that's what we mean by using a mnemonic device to remember the planets in our solar system, again in order from the sun. So closest to the sun to the last planet, which is Neptune, which is furthest away from the sun. When Pluto was still included, it was my very eager mother just served us 9 pizzas. Okay, that's when Pluto was included as a planet. Okay, here's the planets' quick facts, meaning what makes each planet unique. Well, Mercury is the closest planet to the sun. So it's the closest, it's also the smallest, and it was considered a dead planet because it has no atmosphere or water. Venus can be seen at sunrise. The atmosphere on Venus contains carbon dioxide, meaning that it's covered by a thick layer of clouds which traps the heat. This is called the greenhouse effect, so you might remember that from your PLAR geography. Earth, we should know a lot about Earth. It has an atmosphere to help to insulate the planet. It allows Earth to maintain proper temperatures to support life. All forms of water exist. So we have water as solid, liquid, okay, and gas. And as we look at each of the planets next, then you'll see what we mean by how Earth is different from all the other planets. Mars is considered a red planet because it has large amounts of iron oxide or rust. Jupiter Jupiter is the largest planet. It has many colored bands, which are different cloud belts of gases spinning around the surface. It also has what appears to be a great red spot on its surface. So again, keep in mind, these are unique features of each planet. Saturn is the sixth closest to the Sun. It's known for its 1,000 rings, which are made up of chunks of rock and ice. Second largest gas planet. Uranus rotates in the opposite direction from most of the other planets. That's what's unique about it. It has an atmosphere of hydrogen. And finally, we have Neptune. Now, Neptune appears blue because of methane gas. Okay, it has a great dark spot. So now we're going to look at each of the planets more closely. So we said already that Mercury is an inner planet, meaning it's closest to the Sun. Mercury has no moons, okay, and it's very similar to Earth's moon. It rotates on its axis once every 59 days. That means that it takes less time to go around the Sun than any other planet. So if you remembered, for Earth, it takes us like to go all the way around. Mercury takes 88 days to go all the way around, whereas it takes us 365. Temperature on Mercury, so during the day, 400 degrees Celsius, and then at night it just drops to at night it drops to 290 degrees Fahrenheit or 180 degrees below zero. So you can see there's quite a change in the temperature day and night. The Mariner 10 was a spacecraft that flew past Mercury 3 times, 1974 and 1975. This is the only spacecraft to ever visit Mercury. Okay, so key points: is the closest to the Sun, smallest planet. It is a terrestrial planet. Lots of craters like the Moon. It's hot during the day, cold at night. It has no atmosphere. For 1 year, it only takes 88 Earth days. But 1 day equals 1,407 Earth hours, or 58 Earth days. Okay, remember it has no moon. So there's been previous transits that occurred May 7th, 2003, November 8th, 2006, and May 9th, 2016, November 11th, 2019. Okay, after Mercury is Venus. Okay, also an inner planet. It's a similar size to Earth, rotates in opposite direction, so it spins backwards. It is hot and deadly. There's lots of volcanoes on this planet. 1 year on Venus equals 225 Earth days, but 1 day takes 5,832 Earth hours, again because it's spinning backward. Temperature 462 degrees Celsius, which is very hot. And let's see. The first successful flyby of the planet Venus was accomplished by Mariner 2. The American Magellan mission launched on the space shuttle in 1989. They used a radar system to create high-resolution maps of the planet's surface. And then launch in 2005, there was also the European Venus Express mission. Okay, planet Earth, or our third planet, which is our home. It is the 5th largest planet, also a terrestrial planet because it has a solid surface. It supports life with air, water, and land. It has oceans, continents, atmosphere. I mentioned this earlier, 1 year is equal to 365 Earth days. 1 day is equal to 24 Earth hours. So Earth is the only planet that's not named after a god. So if you look at the other names of planets, they are named after gods. What's interesting about Earth is that if you're watching a sunset, someone on the other side of the Earth is watching the same sunrise. Earth is more than 4.5 billion years old. It has one natural satellite, which we call the moon, and oceans cover 70% of Earth's surface. Okay, and then the last terrestrial planet is the planet Mars. It is considered the red planet. It's smaller than Earth. Mars is rocky, dusty, and dry. There's red iron in soil. It has polar ice caps like Earth. 1 year in Mars is 687 Earth days. 1 day, similar to Earth, except that it has 37 more minutes added to it, is 24 Earth hours and 37 minutes. It has 2 moons, Phobos and Deimos. 2 Viking spacecraft landed on Mars. One of their main objectives was to check out the Martian surface for life. What they found was that many of the necessary ingredients for life on the planet, but there was no evidence that there was actually anything alive on the planet. Okay, so those are your 4 inner planets. Now, what are the outer planets? Well, beyond the orbit of Mars lies an asteroid belt. So it's located between Mars and Jupiter, so it's kind of divides inner planets and outer planets. So the asteroid belt separates the inner planets from the outer planets. So planets farthest from the sky, planets farthest from the sun are larger and formed mainly of gases, whereas planets closest to the sun are smaller and mostly solid. They're formed from heavy rocky materials. So in general, the outer planets are totally different from the inner planets. Jupiter, Saturn, Uranus, and Neptune, they are considered gas giants. The smallest of the 4, Neptune, is 60 times the size of Earth. And as their name suggests, gas giants are primarily made of gases. So they are very similar to stars, but they never started shining. So in fact, some scientists suggest that if Jupiter had been a few times larger, it would have become a star. So the gas and ice giant planets take longer to orbit the sun because of their great distances, which makes sense. The farther away they are, the more time it takes to make one trip around the sun. Okay, let's look at planet Jupiter. So this is the largest planet in our solar system. It could hold 1,300 Earths. The gas planet has windy clouds of ammonia and water. It has a red spot with a giant spinning storm. 1 year on the planet Jupiter takes about 4,331 Earth days, which is equivalent to 12 Earth years. 1 day is 9 Earth hours and 56 minutes. The temperature there is very cold, minus 148 degrees Celsius. It has 49 moons. So almost all we know about Jupiter was learned by Voyager 1 and Voyager 2. So these were the two spacecraft that took a tour of the outer solar system in the 70s. We did have recently, in 2011, Juno launched to examine Jupiter's chemistry, atmosphere, interior structure, and magnetosphere. 2016, NASA's Juno spacecraft arrives at Jupiter, and this conducted an in-depth investigation of the planet's atmosphere as well. Okay, Saturn, also known as the ringed planet. It is the second largest planet. It has 7 flat rings made of ice, rocks, and dust. 1 year on this planet is 29 Earth years, or 1,759 Earth days. 1 day is 10 Earth hours and 39 minutes. Temperature, very cold, minus 178 degrees Celsius. There are 52 moons on planet Saturn, and the largest of the moons is called Titan. Voyager 1 flew past Jupiter back in March 1979, and then we also have Voyager 2 that flew past. This was pushed by Jupiter in the same manner. 1980, Voyager 1 probe visited Saturn system, and then 2004, NASA's Cassini spacecraft becomes the first to orbit Saturn. Okay, the next planet is Uranus. Okay, what's interesting about Uranus is that the poles turn to the sun, so it spins on different axes. Very cold and windy. It's the coldest planet. 1 year is equal to 84 Earth years. 1 day is 17 Earth hours and 15 minutes. Temperature gets even colder, minus 216 degrees Celsius. Has 27 moons, and the largest one is Oberon and Titania. January 24th, 1986, NASA's Voyager 2 made the first and so far the only visit to Uranus. March 18th, 2011, New Horizons passes the orbit of Uranus on its way to Pluto, becoming the first spacecraft to journey beyond Uranus's orbit since Voyager 2. And finally, the last gas planet is Neptune. It can fit about 60 Earths inside it. The gas planet is very icy. Windiest planet in the solar system. 1 year on this planet is 165 Earth years. 1 day is 16 Earth hours. Temperature, it's cold as well, minus 214 degrees Celsius. It has 13 moons, and the largest of it is Triton. More facts about Neptune. It's so far away that it took the space probe Voyager 2 12 years to reach it. Neptune is 30 times farther from the Sun as is the Earth. Neptune is a sea blue color because of the methane gas in its atmosphere. So Voyager 2 solved the controversy by clearly showing that Neptune had rings. An individual ring was sometimes thicker on one side than it was on the other. Scientists on Earth could only detect the thicker part of the rings. Okay, next up is the Earth's orbit. So even though you can't feel it, Earth is always moving. It revolves around the sun. So if you look at the picture below, or if you turn to page turn to page 31 in your lesson book. Okay, you have a very similar picture. It shows you that it revolves around the sun. The line with arrows shows Earth's path, remember, or orbit around the sun. That path is called an orbit. Look at the shape of Earth's orbit. Okay, it's like a flat circle. So that flat circle, it's what's called an ellipse. So as the Earth is moving around, so as it orbits the sun, the same time the Earth is revolving around the sun and the moon moves around or orbits the Earth. So all this is going on all at the same time. So as I said, the results of the rotation, the day and night. So as the Earth rotates on the axis, one half of it faces the sun, so that side is experiencing daytime, while the other half is experiencing nighttime. Or you can say one is sunrise, the other one is sunset. The Earth's rotation, so the 1 day completion of it is 23 hours and 56 minutes. We just say 24 hours. Okay, we just round it up. And then as the Earth is revolving once around the sun, we say it's 365.25 days. So we just round it to 365 days, which is called a year. Okay, so remember, one is rotation, the other one is a revolution. Okay, the changing seasons. So Earth has 4 seasons: summer, fall, winter, and spring. So these seasons are always changing. For example, summer will change into fall, fall will change into winter, and then winter into spring. So why do you think seasons change? Well, the sun has something to do with the seasons. So the Earth is tilted at a 23.5 degrees on its axis, so it's not straight up, it has a tilt. So the seasons change as the Earth orbits around the sun. So when you have the northern or southern hemisphere receiving direct rays from the sun, they're experiencing summer. So here you go. You can see Earth on June 21st. And then when those hemispheres receive indirect rays from the sun, they experience winter. So you can see Earth there, December 21st. This is why hemispheres have opposite seasons. So if it's winter in the northern hemisphere, it will mean that it's summer in the southern hemisphere. Okay, if you read, so if you read page 31 in your book. So if you look at the dates on the picture, at the left of the diagram, you can see the position of the Earth when it's winter in Canada. The position of the Earth on March 20th shows Earth's place in the orbit when it is spring in Canada. So right now we're here. Okay, let's try and do some key questions. So from our last class, we did what temperature does the sun reach at the corona? So that was your last key question. So now we will look at key question 13. So key question 13 says identify a characteristic of each planet that makes it unique. So don't just say, well, Mercury is the first planet closest to the sun, Venus is the second planet closest to the sun. Give me some information that shows me that you have read the different planets, both the inner and outer planets, and tell me what is unique about that planet. So it is unique that Mercury is closest to the sun. So if Mercury is closest to the sun, we know Neptune is the furthest away. So it's furthest away from the sun is Neptune. We also know that Mercury is the smallest planet. So two things, closest to the sun and smallest planet. So I'm not looking for a lot of information, but I do want to receive answers that shows that you're showing me what's unique about that planet. You could also go to the quick facts that we looked at. And that one is on page 22. So quick facts about each planet. So if you choose or complete Neptune, we said it was the farthest away. It also has this characteristic, appears blue, okay, because of methane gas. Okay, key question 14. Name the 4 planets closest to the sun. So it says the 4 planets closest to the sun are called inner planets. Name them. So this is where you can use your clue. Remember, my very eager mother. So we know that it starts with Mercury. Next one is Venus. Okay, and so on. You can do the next 2. The 4 planets farthest from the sun are called the outer planets. Name them. So starting off with Jupiter. So just served us, oops. So Saturn, and then you name the other 2. The asteroid belt is located between 2 planets. Identify them. So remember, they divide the outer planets and the outer planets. So 2 planets. And then you write them out. So identify them. And then key question 17 says identify at least 3 differences between the inner planets and the outer planets. So how can you tell if they're an inner planet or an outer planet? Well, I'll give you one. Okay, inner planets are smaller. Okay, and made of rocky materials. So find a second one and then a third one. Okay, so we have key question 13, 14, 15, 16, and 17 completed. Okay, let's continue with the moon. So the moon is the Earth satellite. Satellite means that it stays close to, so the Earth stays close to the moon stays close to the Earth. So the moon is natural satellite. It is made of rock and metals. So it's the Earth satellite. The Earth and other planets are satellites of the sun. So it stays close to the Earth because the Earth's gravity is stronger than the moon's. So if you were to picture a string with, let's see here. So if you have the moon, let's color that there, and you have the Earth, it's like this invisible string because of the gravitational pull. So if you cut the string, then it will drift away. So Earth has oceans full of water. The moon has no liquid water on it. The Earth has an atmosphere around it. The moon does not. So the moon's gravity has an influence on Earth. It affects ocean tides. Now, tides are caused by a natural force called gravity. So because of the gravity, all bodies in the universe pull on each other. So the sun and the moon both pull on Earth. But the moon has a greater influence because it is closer to Earth than the sun. So as the moon pulls on Earth, it makes the water move. So on the side of Earth, near the moon, the water builds up in a wave. So another wave forms on the other side of Earth. This is because the moon is pulling Earth away from the water on that side. So next time you see waves, you might think about, oh yeah, that's why. Okay, the moon is pulling on the Earth and it's making the water move. So tides are caused by gravitational force of the moon. You can have high tide and low tide. You could also try this at home. You can do your own experiment. So if you look at the picture below on page 33, you will need to get some materials. You will need a globe of the world. So if you don't have a globe, you can use a basketball, something round. Maybe you have a cabbage in your fridge, you can use that. So you just need something to represent the world, so a globe. Get a lamp and position the lamp higher than the globe, and then you can make a model of the moon with a ball and a pencil, or you can just get, you can use an orange. So what you do then is you can hold your moon, okay, in front of the lamp, which is the sun. So you can position that. Notice that the moon is on a stick. So then what you can do is you can rotate the moon. So as you spin the pencil or the stick where the moon is on, you can then see that the moon's light comes from the sun. So the sun lights up the moon, and you can try, again, you can try using this experiment. You put the globe about 20 centimeters or about a foot away from the lamp, which is your sun. So turn on the lamp. You have to turn off all the other lights in the room. You might have to close the curtains. You can hold your moon model above the globe. So look at that model. As you're doing it, notice something, what's happening to it. So one part of your model is lit up by the lamp. So that's exactly what's happening to the moon. So the sun shines on it and lights it up. So it's not luminous. We see the moon at night because the sun lights it up. It's like the moon is like a dull mirror. It reflects the sun's light. So, and that light comes to Earth. So all planets reflect the sun's light. Okay, let's do one more key question. Actually, we can do two. Okay, you can do key question 18. Explain why the moon has no atmosphere. Okay, the moon does not have an atmosphere because, and then we just did this, why does the moon appear to change its shape? So the moon appears to change its shape, and this is where we're going to stop. So what I want you to do is when see here, I want you to turn to page 34 and read the section, Does the Moon Have Gravity? So actually don't do 18 yet, because that one is for that one, for those pages. So read page 34 before you do key question 18. Okay, and we'll pick up on Wednesday to do 18 and 19. So today we did key question 13 to 17. Okay, and that's it for today. I'll talk to you again on Wednesday. Miigwech and have a good evening.